Hi everyone, I am Dilip Kumar. Today I am presenting Embedded System Internship Project on Microwave Oven Simulation. So these are the topics that I learned during the internship. Basics of C language, basics of microcontroller and basics of embedded system and various peripherals that are interfaced with PIC microcontroller. So during this internship we implemented one project. Here is an overview of the topics that we will cover in this presentation. Embedded system basics, introduction of microwave oven, project requirements, interrupt service routine, timer, and project implementation demo. So, embedded system. What is an embedded system? An embedded system is a combination of hardware and software components. So, basically, most of the embedded system are microcontroller based system. They are used to perform specific operation. Types of embedded system: standalone embedded system, real time embedded system. As I mentioned before, most of the embedded systems are microcontroller based system. So what is a microcontroller? A microcontroller is a compact integrated circuit that includes a processor, memory, and input output peripherals. So it is designed for specific tasks in embedded systems like robots and IoT devices. There are several microcontroller families. Here are some examples: PIC microcontroller, ARM microcontroller, and 8051 microcontroller. So we discuss about embedded systems and microcontrollers and their types. Now we will discuss about our project. So microwave oven. A microwave oven is a kitchen appliance that uses microwave radiation to heat and cook food quickly. So there are several modes in microwave oven, but in this project we are going to implement four modes. The four modes are micro mode, grill mode, convection mode, start mode. These are the four modes that we are implementing in microwave oven. Let's go through four modes one by one. So first mode, micro mode. This mode is used to cook the food in a traditional way. It uses maximum power of 900 watts. This is first mode. So the second mode is grill mode. This mode is used to cook meat and bread. It is same as micro mode. The grill mode is same as micro mode, but it adds grill mode. So the mechanism is different from micro mode. So that is what grill mode. So the next one is convection mode. In this mode, the user can set the oven to preheat for particular temperature. So the user first preheat for particular temperature and then it takes 1 minute to preheat the oven. So in convection mode, it takes 1 minute to preheat the oven. Then the user can set the maximum temperature the user can set is 180 degrees Celsius. So after preheating is done, then the user can set time as per the requirement. So this is all about convection mode. So the last mode is start mode. So the start mode is the default mode. Whenever the user presses it, so the timer will add 30 seconds. So if it is in 40 seconds, if user presses it, then it will go to the 1 minute 10 seconds. So that is how it's gonna work. So this is all about four modes in the microwave oven project. So we discussed about the microwave project modes. So now we're going to discuss about software tools that we are going to implement in this project. So these are the software tools that we are using. So MPLab XIDE, XE8 compiler, PiximLab, PIC16F877A, 16 into 4 CLCD, matrix keypad, and timer 2. So let's go through one by one. So what is an MPLab IDE? So MPLab IDE is a software tool where we can write code for the PIC microcontroller, we can debug it and we can simulate the project. So this is all MPLab XIDE. So the next one will be XE8 compiler. The compiler developed by Microchip for 8-bit PIC microcontrollers. Basically the XE8 compiler converts C code into mission code that can run on any PIC microcontrollers. It works within MPLab IDE to compile and debug the code. Then the last one, PiximLab. PiximLab is a simulator for PIC microcontrollers. It allows to test without real hardware. So we are simulating our project in PiximLab simulator. We are not using any hardware here. So it supports multiple PIC models and peripherals. So there are various number of peripherals in PIC SimLab like LCD, LEDs, switches, etc. So, it is very useful for learning, debugging, and prototyping before actual hardware implementation. So you can see this is the PIC architecture, PIC microcontroller architecture. There are various peripherals that are interfaced with PIC microcontroller. As you can see, there are like LEDs, buzzers, and digital keypads and matrix keypad. So the peripheral having two arrows indicates that it is a bidirectional, so that it can send the data or it can receive the data. Both it can do. But the peripheral having single arrow, it can do only one work. Either it will send the data or it will receive the data. Only one work it will do. So now we're going to discuss about matrix keypad. Matrix keypad is used when the more number of inputs are required. So when more number of inputs are required, then the matrix keypad is used. So the operation of matrix keypad, rows acts as outputs and columns acts as inputs. As you can see an example in the figure, like 4 into 4 matrix keypad. So the next one will be CLCD, character liquid crystal display. In Pixim Lab, there are two types of displays: 16 into 2 display, 16 into 4 display. It displays all ASCII characters and some special characters. So anything we write in the code, we need to convert into ASCII characters, then we need to print in the CLCD. So this is how it's gonna work. So basically, there are two types of communication modes present in CLCD: 4-bit mode, 8-bit mode. 4-bit mode means so we can transfer the data 4 bits at a time to the CLCD. 8-bit mode means we can transfer the 8 bits simultaneously to the CLCD. So this is what difference between 4-bit mode and 8-bit mode. So then we're gonna discuss about interrupt service routine. So basically an ISR is a software routine that hardware invokes in response to an interrupt. So ISR attends to the request of an interrupting source by clearing the interrupt flag and should save register that may be affected by the code in the ISR. Basically, an interrupt is a disturbance. When interrupt occurs, the MPU completes the instruction executed, then it disables the global interrupt enable. So whatever the address is stored in the program counter, it will send to the stack pointer. This is what about ISR, interrupt service routine. So the last one and the important one, timers. Timers is an important application in any embedded system, which is a default peripheral, which maintains the timing of an operation in sync with system clock or any external clock. So the timers have many applications, like it can use it as a counter or it can use it as to generate delay. So it has very application. So PIC microcontroller includes three types of timers: timer 0, timer 1, and timer 2. So every timer has its own specification. As you can see, timer 0 and timer 2 is a 16-bit register and timer 1 is a 8-bit register. So this is how it's gonna work. So this is all about timers. So thank you. This concludes my presentation now. Let's move on to the demo session. So this is the MPLAB XIDE. At first, we need to create the file called as microwave oven. So this was the main code. So this was the code for matrix keypad. So we need to read the key that user pressed in the matrix keypad. So this was the code that can read the key user entered. So this is the code for the timers where we need to initialize the timers. In this project, we are using timer 2. So as you can see, timer 2 is equal to 1. Remaining timers are 0. So this is the code for ISR, interrupt service routine. So this is the code for CLCD. So we need to print some characters in the CLCD. So we are using this. So this was the code for microwave C. So remaining are all our header files. So in that header files we define macros and like that. So let me show you the main code first. So this was the main code. We need to configure it first. So at first we need to read the key from the user. So you can see here we are reading the key from matrix keypad and we are storing it the operational flag. If the key press 1, if the key is 1, then it will enter into the micro mode. If the key is 2, then it will enter into the grill mode. So this is how it's gonna work. Based on the key press, it will change the mode. So you can see operational pause. So here we are using switch case statement. So if the operational flag is power on screen, then we are calling on power on screen function, but we are not implementing the function here. We are just calling the function power on screen. So we are implementing the function in microoven.c. As you can see here, we are defining, here we are implementing this function power on screen. As you can see, clc underscore push means it it indicates that it can print a character. So clc.push is used to print a character. Clc.print is used to print a string. So this is how it's gonna work. When we call the power on screen, this will be implemented. So the powering on micro oven will be displayed in the CLCD. So like that, for clear screen, for display menu screen, that is how it's gonna work. So here we are just, if it is a menu screen, we are calling the menu screen function. So here we are defining the function. In microoven.c, we are implementing this function. So this is all about the code. Sorry for the disturbance. So we need to build it. So I am clean and building. So as you can see, clean is successful. So as you can see, there are so many warnings in the code, but most of the warnings are avoided. Only errors are considered. So as you can see, build is successful. After build is successful, you can get the hex file. So now I need to simulate this one. So I am opening Pixim Lab. So as you can see, this was the Pixim Lab interface. This is the PIC microcontroller. These are the various peripherals. This is the fan, buzzer. This was the matrix keypad that we are discussing in the PPT. And this is the 16 into 4 CLCD. So I need to dump my file. So I am using file load hex. So my hex file is saved in this. So as you can see the path here. So I'm my dumping my code. So as you can see, after dumping my code, you can see powering on micro oven screen is visible. So after some time, after some delay, you can see it enters into the menu screen. So you can see the menu screen. There are 4 modes: micro mode, grill mode, convection mode, and start mode. So in these 4 modes, we need to see how every mode is working. So this was the matrix keypad. If I enter 1, it enters into the micro mode. If I enter 2, it enters into the grill mode. If I enter 3, it enters into the convection mode. So this is how it's gonna work. So at first I'm pressing 1. Let us see what will happen. So if I press 1, it's showing power equal to 900 watts. As I mentioned in the PPT, the micro mode will run at 900 watts. So I can see it entered into the set time. So we need to set the time. So I am entering 10 seconds. So but it is too low. So I need to clear it by pressing star. You can clear the time. As you can see, as of I pressed star, the time is cleared. So again I'm pressing 15. Yeah, it's fine. Then I'm pressing hash. So enter. So as you can see, after I'm pressing hash, the time starts the counting down and the fan is on. So if I press 4, it runs again. If I press 5, so it will pass the time and the fan will turns off. So this is how it's gonna work. So we're gonna see what will happen after 10 seconds. So the time is counting down and the fan is on. So as you can see, so after the time up, enjoy your meal. So it is how it gonna indicates, and after the time it returns to the menu screen. So as you can see, the 4 modes are available. So now I'm going to check grill mode. So I entered in the grill mode. So as I mentioned in the PPT, the micro mode and grill mode both are same, but the mechanism of both are different. So you can see here it is same as micro mode. I'm entering time 16 seconds. So enter. So it is same as the micro mode, start, pause, stop. So I don't need to waste my time. So I'm entering stop. While I press stop, it returns to the menu screen. So as you can see, if I press 6, it enters into the menu screen and the fan is turned off. So the first two modes are completed. Let's go to the third mode, convection mode. If I press convection mode, you can see we need to set the temperature first. So I am entering 120. So this was the temperature. So I am pressing hash. So as you can see, after pressing the temperature, the preheating will start. So the time remaining in the preheating is 60 seconds, which indicates 1 minute. So as you can see, it is counting down. So we need to wait for 1 minute for preheating. So let us wait for 1 minute. Thank you. As you can see, after the preheating time, it enters into the set time mode. So here we need to set the time. So I am entering 2 minutes. No, I don't want 2 minutes. So I am clearing it. So I will keep it as 1 minute. Let's see. So as you can see, so it's counting down and the fan is off, and remaining will be the same function. Start to resume it, while pause will pause the fan and the timer, then stop, it returns to the menu screen. So I don't want to wait until 40 seconds, so I am returning to the menu screen. So it enter after I pressing 6, it enters into the menu screen as you can see, and the fan turns off. So the last mode is start mode. So I am pressing 4, so it enters into the start mode. Start mode is the default mode. So what is the use of start mode means, if I press 4, it adds 30 seconds. So as you can see, previously it was 20 but it came to 50. So if I press again, so it enters into the 115. If I press again, so it added 30 seconds. So this is how the start mode will work. So I want to come back. So 6, so it enters into the menu screen. So thank you guys. This is what all about micro oven project. So thank you everyone.